Oh, geez. See, Sarah said there was a curse, and getting the cables right is always kind of hard. There we go. Hey, everyone. I'm excited to be speaking to all of you about building for the web. And what a great time to be talking about the web because, as you may have heard, earlier this year, we actually celebrated a big anniversary for the web. That's right, the web is now 10 years old. Tim Berners-Lee shared his vision for the World Wide Web in March 1989 in a paper titled Information Management, a Proposal, which his boss at the time heralded as vague but exciting. He said, the dream behind the web is of a common information space in which we communicate by sharing information. Its universality is essential. The fact that a hypertext link can point to anything, be it personal, local, or global, be it draft or highly polished. And he worked on this idea at CERN for the next few years, and in 1993, we all got to play along with the release of the free Mosaic browser. And it's been a wild ride in the years since then. Of course, now there's tons of websites, new experiences and ideas, and companies built around the web. Many I'm sure you've heard of, or you might even work for one. And the browser war has officially begun. Just in the last couple of years, we've gotten to try a bunch of new web browsers. So you can be a webmaster no matter what operating system you use. And these browsers have been making sure that the web keeps getting more powerful. And over the last couple of years, we've seen the introduction of JavaScript, cascading style sheets, plugins that let us do new things like flash animations, and support for future experiences like mobile and virtual reality devices. All of this, and the market seems like it couldn't love the web more. So today, I'd like to share some highlights of the new technologies that have made all of this possible. Where we are now, here in 1999, and then a glimpse into the future of the web. But first, let's start with the basics. What is the web, and how does it work? Well, a web page is just a normal file. It's a rich text document written in HTML, the language of the web, which contain Tim's clickable hyperlinks that refer to other web pages. And these hyperlinks come in the form of a URL that has two important parts. The first part is the website, and the second part is the web page. And with a little bit of magic, your browser finds the actual physical computer also connected to the internet for that website, and then asks it for the requested web page. That computer runs a piece of software called a web server, which translates the requested web page to an actual file stored on its file system. It opens that file and sends it across the internet back to your browser using a protocol called HTTP, and this is amazing. But over the last few years, we've seen an evolution from serving static files or websites to dynamic programs or web applications. This lets us make totally new kinds of experiences where the program is not being run on your computer, but on the web server. And this evolution started with CGI. And CGI is dead simple, but super clever. CGI extends what a web server can do beyond just reading files by saying, if the requested file is within a certain directory, and we usually use CGI bin by convention, then that file is a program. And rather than just opening the file, it executes it with a handful of environmental variables set from the HTTP request, and then sends the program's standard out back to your browser over HTTP. And this is so cool because literally any program can now be a web application. It could be anything from a simple shell script to a complex compiled C++ program. Of course, doing anything other than simple tasks is pretty annoying in a shell script, and C++ takes years to master and about as long to compile. Scripting languages like Perl are a great compromise, and they've become pretty popular for CGI, but Perl wasn't really designed with the web in mind. And here, PHP has really taken off. PHP was created a couple years back in 1995, but really got interesting to our web community last year with the release of PHP 3. It's an open source programming language, and currently the best way to get started on the web. Now, I say programming language because its creator said that he never really intended it to become a programming language, though it definitely is Turing complete. It's become popular since it's really the first language built for the web. Its original goal was to process web forms and generate web pages, and it does both very well. And PHP feels revolutionary because it's blurred the line between files as web pages and programs as web applications. For instance, any typical HTML file is actually a valid PHP program. Now, this one doesn't do anything interesting yet. It's more web page than web program at the moment. But we can insert a PHP tag, and now we're in application land. So, for example, we can access some state from a submitted form or a cookie, use that to query our database, and then go right back in HTML, but with fresh data interleaved. And part of why I like PHP so much is that it's super easy to learn once you already know HTML. You can incrementally include dynamic logic into existing HTML files, and it scales up to everything that you could do with Perl. And PHP is also free and open source. And as part of what I've recently heard called the LAMP stack, which stands for Linux, which is the free and open source operating system. Apache is a free and open source web server that supports CGI. MySQL is a new free and open source database. And then, of course, PHP. These are all the tools you need to build and serve web applications. And if you're not too familiar with open source software, this might not sound like a big deal, but it means that PHP and the rest of the LAMP stack is constantly improving from the web community's contributions, and anyone can use it without payment or licensing concerns. In fact, I predict that the recent excitement around the web will inspire a future generation to learn to program, and PHP and the LAMP stack will make it easy to do so. And as we look ahead, we can reflect back to Tim's dream. There was a second part of this dream too, dependent on the web being so generally used that it became a realistic mirror, or in fact the primary embodiment of the ways in which we work and play and socialize. That once the state of our interactions was online, that we could use computers to help us analyze it, make sense of what we're doing, where we individually fit in, and how we can better work together. And this second part has yet to happen. And all of this makes me wonder, what will the web look like in 10 or 20 years from now? Before I get too far into all of this, I should introduce myself. My name is Lee Byron, and I lead web engineering at Robinhood, where we're democratizing access to our financial system. I'm also one of the creators of GraphQL and the director of the GraphQL Foundation. I was an early contributor to React, Relay, and other software from Facebook, and I'm responsible for many other open source projects that you might use, such as TestCheck, Immutable.js, Data Loader, and many others. And I'm not actually a time traveler, just occasionally detached from reality. I'm fully aware that the current year is 2019. And that actually means that we celebrated the proposal for the web's 30th anniversary, which means that our open source web developer community is well over 20 years old. And it's fun for me to look back on 1999 because that's when I first got involved with the web and taught myself to program by learning PHP and, building Pokemon fan sites with the LAMP stack. And in the decade after 1999, the web and really PHP exploded in popularity and relevance. The fact that it was free to use, easy to learn, and scalable led to a new post-bubble wave of companies built with LAMP, including some current giants. Wikipedia in 2001, WordPress in 2003, and Facebook in 2004. And while PHP gets a lot of well-deserved criticism, it's still relevant and probably way more popular than you think. Today, over 80% of websites are powered by PHP. In fact, 30% of the web alone is specifically powered by WordPress. This is crazy. And I spent most of the last 10 of the web's 30-year history working at Facebook, where I saw the evolution of PHP, LAMP, and complex web apps. And what's most fascinating to me is that now, 20 years later, the programming model and mental model of the web feels largely the same as it did back when these tools were first introduced. Of course, at the same time, we've tackled growing complexity, have built far richer experiences, grown our community 1,000-fold, and scaled to billions connected to the web. And I see a pattern behind this progress, a relationship between three kinds of advancements: better and more powerful abstractions, clear and more expressive syntax, and improved and refined mental models. In fact, these three influence each other in a sort of loop. We build better libraries and abstractions, which unlocks new capabilities and better performance. We introduce new programming patterns, APIs, and ultimately new syntax into our languages to better express ourselves in terms of these abstractions. And that creates clarity, which leads us to improve our mental models, how we think about what we build. So today, I want to illustrate this process through a handful of stories and specific examples that I saw unfold at Facebook across three problems we've all become familiar with: rendering views, managing state, and fetching data. I want to start with rendering views because it's so much of what we focus on as front-end engineers, and it was also PHP's killer feature. PHP really meshed well with the mental model of a web app as a mix of dynamic content interwoven with static content written in the lingua franca of the web, HTML. And PHP kicked off this era of the template language, and more template languages followed, like embedded Ruby or ERB in 2004, Mustache templates in 2009, and plenty more. It made it really easy to start with static content and then introduce dynamicism over time. But as you started to build anything complex, you quickly realized the need for full Turing complete logic, which means these simple template languages either evolved into their own weird programming languages like PHP, or remained crippled and limited in use like Mustache. And even templates with rich logic remain difficult or awkward to modularize or reuse without relying on global variables or just kind of losing most of the benefits of the template syntax. And then there's security, which templates often leave totally up to you. Naive, simple-looking PHP code usually suffers from critical SQL injection or cross-site scripting vulnerabilities. These, in particular, were constant thorns in the side of early Facebook. So to resolve these issues, Facebook built a framework called UI Component. It's funny how this is now a pretty general term. UI Component was heavily inspired by MVC frameworks at the time and the browser STOM API. So for example, a button might be called UI Button Component, which would be a subclass of UI Component. And to use this, you would just instantiate this class with new. You can then configure it with a chain of method calls, add children UI components and client-side behavior with a DOM-inspired API, and then call render to get the complete resulting HTML. And this solved all of our problems with templates. Now building a UI was just code. No need to invent a new Turing-complete language. We have an API designed for modularity and reuse. And importantly, what we're building here is a tree of UI component instances rather than a stream of concatenated strings, which is what templates usually are. So it's much easier to systemically solve security issues by automatically escaping content correctly based on where it occurs, or automatically including CSRF tokens and forms, even if you don't know what that is. Security issues solved. Reuse also led to a standard component library, which improved product design consistency. And this all sounds great, but the one huge downside was that every time we refactored a bit of UI from templates to UI components, we just couldn't shake the feeling that the new code was just worse. It was more verbose and harder to read, and there's definitely a reason why people prefer to write HTML over directly using the DOM APIs. Luckily, meanwhile, there was the skunkworks projects underway at Facebook to rewrite the site from scratch in an effort to achieve better performance and shed technical debt. And this, of course, didn't work at all, but the effort yielded some pretty super interesting new technologies and ideas. one of which was an extension to PHP called XHP. So XHP introduced a new XML-like syntax to PHP, inspired by the ill-fated E4X JavaScript project. However, unlike E4X, PHP didn't try to add any new runtime behavior for working with XML. Instead, all it did was just add syntax sugar atop instantiating typical plain old PHP classes. It made it much easier to describe a tree structure of class instances, and it was almost as easy to read as HTML. This was a perfect match for UI components. The implementation details remained largely the same, but the syntax returned to what we loved about templates. Though now we actually had the added benefit of catching errors like missing closing tags as syntax errors at development time, rather than a broken view or invalid HTML in production. How many of you remember those HTML validator apps where you'd like punch in your website and it would check that your site's markup has errors or not? Anyone use those? Yeah? I haven't used one in years because of features like this. So the better abstraction of UI components with the better syntax of XHP further clarified our mental model of building modular UI by defining them in terms of other modular UI. And that allowed us to replace an imperative, mutable DOM-style API with a more declarative functional API. So you may or may not have heard of XHP before, but even if you haven't, you're probably hearing all of this and thinking, JSX. Well, you may not know this, but the initial versions of React did not include JSX. The author of React, Jordan Walk, had been working on the ideas behind React before he even joined Facebook. And the idea to change the syntax of the language along with a library of code was just not something on his mind at the time. However, as other front-end engineers at Facebook first started to see React, they immediately responded with skepticism. Their mental models had already been shifted by XHP, and it wasn't until including JSX that React started to be adopted across Facebook. So imagine how surprised we were when we open-sourced React in 2013. People hated it. Specifically, they hated JSX. Y'all were mean. Facebook engineers had already adjusted their way of thinking about developing UIs thanks to XHP, but it would take another couple of years for the rest of the web community to come around to JSX. And I think this refinement of abstraction, syntax, and mental model continues with post-React UI libraries like Vue and Svelte. These take it full circle, all the way back to this original compelling idea that any bit of HTML is also a valid component. And it feels familiar in a way, like the simple PHP code from 1999, where any HTML was also valid PHP. Early web apps actually used very little JavaScript. Really, the first 15 or so years of the web featured applications with an enviously simple model for managing state. Load a page, click a thing, which loads another page, where maybe you submit a form, which again loads another page. And the programming model for interacting with state over time in this pattern was simple. Read a form or a cookie, update some database state, write a cookie, and then write some HTML. And importantly, PHP apps are not treated as long-running stateful services. Each request starts with a clean slate, and each URL route is associated with a different PHP file to be run, further simplifying routing and state management. It was a novel and unique runtime that we haven't really seen that many other examples of until recently, where now we associate these properties with serverless and Lambda. And all of this really was kind of the OG one-way data flow for UIs. Of course, this means that every state transition is a full page load, and in 1999, that happened over a dial-up connection, which was painfully slow. And it also doesn't allow for the rich client-side or event-driven apps like chat. Facebook Chat was the predecessor of Messenger and really the first client-side JavaScript-heavy experience on Facebook. It was built in 2008 and followed the well-established MVC pattern at the time. This was 2 years before Backbone.js would come out. But for years, the same bug kept popping up over and over again, the zombie notification. Something on Facebook would light up as if you had a message, and excited you'd go to click on it, only to find no new message for you. This was actually the first project that Adam Wolf, my longtime manager, worked on when he first joined Facebook. He's actually now VP of Engineering at Robinhood, where I work, so you should come join us. We're a pretty fun crew. Excuse me. So he wanted to first better understand what exactly was causing the problem. But at the time, chat had no automated tests and was actually pretty difficult to test because it relied on subscribing to various events which came from many different sources. And that led us to build a new kind of JavaScript test framework with mocking as a first-class concept, Jest. We were actually using Jest at Facebook for almost 4 years before we open-sourced it. So with tests in place to catch regressions, we now much better understood the problem. Events that resulted in updates to the chat UI could come from server-pushed events, metadata in a page transition, or just people directly interacting with the chat UI. And chat itself appeared in 3 different places: in the messages view, in the chat bar, and in the notification icon in the top corner. And each of these different views had their own logic for handling events and keeping themselves up to date. This was just impossible to keep track of in your head, and it led to repeated inconsistencies just because of missing edge cases in the code. And this is where the zombie notification came from. So the solution was to rewrite chat in a new architecture. They took the mental model of simple server-side state, but implemented all of it in client-side JavaScript. Any event which could alter state changed from an event emitter to instead be represented by an action. And an action was just a declarative description of what should change. This declarative action was then dispatched to a store, much like you would send a post request to a simple, stateful web server. We called this architecture Flux. Of course, for this simple web server style approach to be complete, the result of dispatching an action should be similar to what happens in response to a web request. The entire page should be replaced with the new response, which includes the result of that change. But that would be very different from how we were building client-side UIs at the time. If you looked at the callback for a new message event, it would be directly constructing a new DOM node and calling append child on the chat window. And changing from this to replacing the entire view wouldn't necessarily be better because it could be slow, it could flicker the UI, and it could lose things like scroll position or whatever you happen to be typing at the moment, particularly important for a chat UI. These, of course, were some of the motivating reasons for building React. Flux and React together provided a much better abstraction for managing state, which allowed us to bring the one-way data flow of simple PHP apps of the 90s to the dynamic JavaScript clients of today. Of course, now few of us use Flux as it was presented 5 years ago. We've, again, continued through the loop of better abstractions, clearer APIs and syntax, and more refined mental models. It led us to Redux, using connect decorators on our React components, and thinking of state as reducer functions. And React itself has also continued through this loop, adopting class syntax, clarifying the mental model of component lifecycles, improving the abstraction with React Fiber, and further simplifying syntax with functional components in React hooks. And React functional components with hooks, it feels familiar. Like the simple PHP code from 1999 where you just wrote functions which declared your state and then rendered a complete view with templates. So looking back, I think part of what made LAMP so empowering was just how easy it was to set up and use a MySQL database and create data-driven views. Early simple web apps had easy-to-follow imperative code. Query your database with SQL, save that result to a variable, and then render a template with that data. This worked great in the era where a web app was just a single instance of PHP and MySQL installed on one machine. It was simple, it worked well, and it was pretty easy to maintain. But it couldn't really scale past thousands of users or to large teams of developers or to more complex data-rich applications. Of course, Facebook needed to do all of these things, especially as they started to work on new features like Newsfeed. Newsfeed made data fetching challenging because there weren't really performant SQL queries that could get everything that you need for a feed of very different kinds of stories. And even if there were, Facebook used memcache to improve performance, and that required that you had cacheable key value pairs. So building newsfeed with memcache led to the dreaded n+1 problem, attempting to load multiple values from a list of values, each independently, leading to many blocking queries per page load running one at a time. This could be very, very slow. So Facebook solved this by building a library called Preparable. A preparable was really just a simple state machine. It was a class instance with a method called prepare, which contained a switch statement. And it was passed in an argument with a number indicating which state it was currently in. Each step either enqueued some data to be fetched and returned true, which meant that it should later advance to the next state when that data was available, or it fetched some additional data and then returned false to indicate that this was the last step and after which it could be considered completed. So a preparer then collected a list of relevant preparables on the page, each focused on a specific need, like one per story in the newsfeed, any notifications you might have, and so on. And then it called prepare on all of them. When all preparables were stuck waiting for data, a single batched request is sent to memcache for everything requested up to that point. Then it returns and advances the state of each preparable, and it just continues like this in a loop until all of the preparables are completed. This solved the n+1 problem since it resulted in the fewest batched memcache requests, regardless of how complex the page was, while at the same time allowing each element of the page to have independent logic. This allowed Facebook to grow far more complex and data-rich while maintaining both good performance and a modular, maintainable codebase. Preparables worked really well, but as you might expect from that code snippet, they became a frequent source of bugs. It was really easy to accidentally forget a return or break statement in a switch case, or maybe to forget to change a number after refactoring something. But we stuck with it, and we did our best to catch these things during code review. And I thought this was super clever and really novel, until I learned about generator functions. So generators are functions that, rather than running completely top to bottom before returning to the caller like normal functions do, they let you yield control back as many times as you want, and then the caller is responsible for asking it to carry on by calling a next method. So generators have been around in some form since the 70s, but were more recently popularized by Python in 2001, and then introduced to JavaScript by Mozilla in 2006 as a proposed addition to ES4. And then ES4 was canceled after years of hard work, and later Harmony was an effort started to bring back some of the ES4 features, but that was taking forever, and the Harmony effort was later renamed ES6. So actually, generator functions took nearly a decade from Mozilla's first version to shipping everywhere. That happened pretty recently, actually. So perhaps unsurprisingly, JavaScript developers at the time were pretty apathetic. They had no confidence Harmony would ever ship in browsers and started to take it upon themselves to build tools which allowed them to extend the language before browser support was available. You probably all use or at least heard of one of these, Babel, which actually was originally called 6-5 because it translated ES6 to ES5. But even before that project, one of the first of these translators was Regenerator. So Regenerator specifically transformed generator functions into JavaScript that any browser could run. This blew my mind. I thought the generators were such a new runtime concept that this shouldn't be possible. So of course I had to learn how it worked. So I wrote a simple generator function, put it through Regenerator, and what came out the other side? A preparable. I learned that a generator function was just clear syntax for describing a state machine that they can be translated into, and with exactly the same kind of switch statements that we were already using in preparables. Generator functions are syntax sugar for preparables. And at Facebook, later enhancements to preparables included nested child preparables, handling errors, and adding loops and other complex state transitions. And each of these align exactly with generator function syntax like yield star, try catch, and just plain simple control flow, like for and while loops. And so generator functions gives us syntax for state machines intended to produce multiple values over time, but preparables are really about complex asynchronous behavior that results in a single final state. That actually aligns much better to a different ES6 feature, promises. So each step in our preparable could kind of be thought of as like a chain of JavaScript promise then callbacks. So by 2012, we actually spotted an even better fit. C# had introduced async functions, an unholy union between the state machine modeling syntax of generator functions with the asynchronous abstraction of promises, or C# called them tasks. Light bulbs went off, and Facebook again extended the PHP syntax to include async and await, and undertook an effort to replace preparables with easier to understand and far less error-prone async functions. These extensions later became the hack programming language, where improvements to async programming actually continue to this day. Earlier this year, they released even more updates to how to manage async and await. This further clarified the mental model, and later, async functions and XHP components merged to create Gen XHP, where data fetching and component rendering became co-located. That led to better encapsulation of complex data-driven components, and this final evolution was happening right as we were starting work on GraphQL. And I think you can kind of see the influence of async functions and preparables on both the syntax and execution of GraphQL queries. In fact, we later realized just how important preparables were to GraphQL that we were inspired to create an open source data loader to help solve the exact same N+1 problem for JavaScript. And the resulting mental model from using Gen XHP on the server inspired front-end engineers at Facebook to build Relay, which borrowed the idea of co-locating data needs with UI components from the server to the client using GraphQL. Multiple times, we cycled through this evolution of better abstractions, clear syntax, and refined mental models, which led to ideas like Gen XHP, GraphQL, Relay, and React Suspense. And it feels familiar, like the simple PHP code from 1999, where you just asked for what you wanted and then rendered what you needed. So I think LAMP has become so popular in large part because PHP has provided a compelling mental model for expressive syntax for building web apps. 20 years later, it feels like in a way we found ourselves back to where we started. And that's thanks to the steady march forward of better, more powerful abstractions, clearer and more expressive syntax, and improved and refined mental models. And this has helped us build richer, faster, and more complex experiences, grow our community to millions of developers, and connect billions of people to the web. And now, with the benefit of hindsight, it's not that surprising to me that Facebook has been responsible for pursuing a lot of these ideas. It was originally built by people who, like me, learned programming by building things for the web in 1999 with the LAMP stack. As Facebook grew in product complexity, popularity, and company size, it encountered these challenges, became frustrated with existing solutions, and drew inspiration from the simplicity of the early web. And that led to better view rendering with XHP, React, and JSX, better state management with one-way data flow, Redux, and now React hooks, and better data fetching with preparable style batching, async functions, GraphQL, and now React Suspense. And I don't think we're anywhere close to done either. There are still plenty of problems to improve upon which could benefit of this progression of better abstraction, syntax, and mental models, maybe again inspired by ideas from decades ago. So as we look to the future, again we can turn to Sir Tim about his dream for the web. Reflecting on this milestone of 30 years, he said, "Today, half of the world is online. It's a moment to celebrate how far we've come, but also an opportunity to reflect on how far we have yet to go. The web has become a public square, a library, a doctor's office, a shop, a school, a design studio, an office, a cinema, a bank, and so much more. Of course, with every new feature, every new website, The divide between those who are online and those who are not increases, making it all the more imperative to make the web available for everyone. The web is for everyone, and collectively, we hold the power to change it. It won't be easy, but if we dream a little and work a lot, we can get the web that we want. All of which makes me wonder, what will the web look like in 10 or 20 years from now? So I look forward to building the future of the web with all of you. And once again, thank you, Full Stack Fest, for having me.